Hi, Modern World History students. We're continuing with unit number 6, the First World War, and we've moved on now from the things that caused the war to the way that the war was being fought. So we've moved on from question number 1, which is why do we fight, to question number 2, how do we win? And as we've seen, that question had led to some very difficult situations for soldiers on the battlefields, particularly on the Western Front. Trench warfare had led to a kind of a nightmarish existence for the soldiers who had to live and fight in the trenches. And it seemed like there was no way to win. It seemed like the advantage that the trenches and the barbed wire and the machine guns and the artillery gave to whoever was playing defense, whoever was defending the trenches, it seemed like that advantage was so great that neither side could ever gain an advantage and neither side could ever progress toward victory. It seemed like the war had stalemated and there was no end in sight for that stalemate. And so a lot of officers on both sides began to put a lot of their faith in new technologies that were beginning to emerge during this war, hoping that these new technologies could help break the stalemate and change the outcome of the war. So we're going to focus on technologies, and we're going to be at the top of page 13. So one of the new technologies that had led to a lot of high hopes amongst officers was the tank. And you can see that if you have a little bit of knowledge of what a tank is, this World War I era tank doesn't look a lot like the tanks that we think of in sort of more recent wars, World War II and forward. For one thing, the thing that maybe seems to be missing would be the rotating turret. So you would expect on top that there would be a rotating turret with a big gun sticking out of it. And that's true. More recent tanks have that big rotating turret with a gun that's used to engage and destroy enemy troops, tanks, and trucks. But during World War I, the tank didn't have that. And as a matter of fact, World War I tanks moved along very, very slowly. Um, the World War I tank crept across the battlefield at a rate of about 3 miles per hour. So it was very, very slow. And yet, neither of these things really mattered. The fact that it has no rotating turret with a big gun on it, the fact that it creeps along at about 3 miles per hour, that really wasn't a problem during World War I. And the reason why I say that is that the purpose of the tank during World War I was not to be kind of the main offensive weapon on the battlefield. The purpose of the tank during World War I was to support the infantry in its advance across no man's land. So the idea of the tank was that it would essentially serve as a kind of a giant moving shield or a giant moving wall that would protect that would protect infantry from enemy rifle fire and protect them from enemy machine gun fire. The infantrymen could walk across no man's land behind the tank, and enemy rifle fire and machine gun fire would simply clank off the tank's armor, and therefore the soldiers could be protected behind the tank. They didn't travel in the tank. That's not what this is. This is not a personnel carrier. They were walking behind the tank. The other thing that the tank could do for them was it could roll over barbed wire. So when the tank got close enough to the enemy trenches that was encountering barbed wire, unlike the soldiers who would get caught up in the barbed wire, the tank would simply roll over it and smash it and create gaps in the barbed wire. And then the soldiers moving behind the tank could simply pass through those gaps and they could attack the enemy soldiers in their trenches. So the tank was expected to really potentially change the way that trench warfare was being fought. First of all, by protecting infantry who were crossing no man's land from enemy rifle fire and machine gun fire. Number two, by creating these gaps in barbed wire that the soldiers could then pass through to attack the enemy in their trenches. Unfortunately, and that's why it didn't matter that it only went 3 miles per hour. You didn't want it to go much more than 3 miles per hour. You didn't want it to get because the average human being walks 3 miles per hour. So, you didn't want this thing to get way out ahead of the soldiers it was supposed to protect, right? The fact that it only went 3 miles per hour was fine. The fact that it didn't have a big gun was fine. It's not engaging enemy troops. It's really just there to support infantry soldiers crossing no man's land, protect them, and open up gaps. Unfortunately, at first, it didn't really work wonders because remember that what we said, um, more than 70% of injuries suffered on World War I battlefields were not suffered from rifle fire or machine gun fire. Do you remember what they were suffered from? Do you remember? It was suffered from high explosive shells being fired by enemy artillery. So as you were crossing no man's land, enemy cannon, enemy artillery were firing at you, and these high explosive shells. Remember, they exploded above the ground typically, and then they projected bits of shrapnel down onto the soldiers who were below. This thing might burst 10 or 20 feet above the ground and blast shrapnel down at the soldiers below. And so, unfortunately, the tank did not provide soldiers against that. They were walking behind the tank, which meant that it helped protect them from rifle fire and machine gun fire. But artillery fire, which was projected up and over, was blasting down from above. And so, unfortunately, although tanks seemed to hold out the promise of transforming trench warfare and helping to even up the advantage that was enjoyed by the defense, in the end, it didn't really do it because it couldn't protect infantrymen from these high explosive shells bursting over their heads. So tanks really did not change the way that the war was fought significantly. Maybe a little bit more at the very end when they learned how to use them in combination with other types of weapons. But it didn't change the way that the war was fought. It did not break the stalemate in the trenches, and it didn't impact the outcome of the war. Air power began to be used more frequently during World War I. And at the beginning of the war, the kind of air power that was being used was this kind. So this is a blimp or a dirigible or a zeppelin, depending upon what country you're from. They call it different things. It is what is called a lighter than air aircraft. And what that means is that it stays in the air because it's filled with a gas that is lighter than air. It's at least less dense than air. So, something which is less dense will float on top of something that is more dense. So, air floats on top of water. So if you have a inflatable raft or an inflatable boat, it will float on top of water because air is less dense than water. Well, there are certain gases that are less dense than air. Hydrogen, for example, is less dense than air. Helium is less dense than air. So if you have a balloon filled with hydrogen or helium, that will actually float in the air because it's less dense. So a lot of these early aircraft that were used in the war were what we call lighter than air aircraft. They were maintained in the air, they floated in the air because they were filled with something less dense than air, like generally in the case of World War I, hydrogen, because hydrogen is much easier to come by than helium. Hydrogen you can make simply by passing an electrical current through water. Water is H2O, right? A hydrogen atom bonded with two hydrogen atoms bonded with an oxygen atom. When you pass an electrical current through water, it separates those out and you can collect the hydrogen. So hydrogen is easy to come by, helium isn't. And so as a result, most lighter than air aircraft during World War I were kept afloat because they were filled with hydrogen, which is less dense than air. The purpose of these aircraft was to observe the enemy. Think about how in the time of Napoleon Bonaparte, battlefields were relatively small. They were maybe a mile wide or maybe a mile deep and 3 miles wide. And so Napoleon Bonaparte could observe the entire battlefield simply by climbing up on top of a hill or even maybe sitting up on top of his horse and observing through a telescope. But in World War I, everything had changed. The battlefields were 20 or 30 miles wide and 3 and 4 miles deep. And so you couldn't observe the battlefield anymore simply by climbing on top of a hill with a telescope. You needed a much more elevated position from which to observe the battlefield. And that's what these blimps or dirigibles allowed. They allowed an observer to get a truly elevated position above the battlefield from which they could look down on the battlefield and they could observe the enemy position. So they could see where the enemy forces were strongest and where they were weakest. So if you were planning an attack, if you were planning to go over the top, over no man's land, your observations made from your elevated position could tell you where the enemy had the smaller or greater concentrations of troops. help you decide where to make your attack. Or if you saw enemy troops massing in a particular sector of the front, you might expect that they were getting ready to attack you. So that was an important function of air power, was observation of enemy troops. The other thing was that during World War I, artillery, cannon, had improved so much. They could fire a high explosive shell 3 or 4 miles, some of them 10 or 12 miles. Whereas in Napoleon's time, the range of a cannon was half a mile. And so again, through your telescope, you could observe and determine whether you were hitting your target. But now during World War I, with cannon that could fire a shell 2, 3, 4, 10, 12 miles, you can't just observe through a telescope to determine whether it's hitting its target. No, you need, again, from an elevated position, you needed an observer who was able to see that and then radio back to his artillerist using his radio, hey, you're overshooting the target. You need to increase your angle or decrease your charge or whatever. So during the First World War, lighter-than-air aircraft were used not only to observe enemy troop positions and the enemy lines, but also to report back to the artillerist to help them hit their targets more accurately. Now, the problem with that lighter-than-air aircraft was, as I mentioned, it's filled with hydrogen, which is highly flammable and actually explosive. And of course, look, this is a very large target. It moves very slowly. And so as a result of that, it was very easy for enemy artillerists to sort of increase the elevation, the angle of elevation on their cannon, and blast a high explosive shell, up into the air. And if that high explosive shell would burst anywhere near, if it would explode anywhere near this blimp filled with hydrogen, if any of that hot metal smashed through the sort of canvas covering, so this is made out of cloth, sort of a canvas covering, if it would smash through there, that hot burning metal, that superheated hot metal would break through there and it would ignite the hydrogen inside of this, and immediately that hydrogen would explode. The entire blimp would be consumed and it would be destroyed. And so these lighter-than-air aircraft, although they were effective, they were also very easy targets. It was very easy to destroy them because they were filled with explosive hydrogen and they were big and slow. And that's why airplanes increasingly took over the role that lighter-than-air aircraft like blimps and dirigibles and zeppelins had played. Airplanes were a brand new invention, relatively speaking. The Wright brothers had made the very first powered flight in an airplane at Kitty Hawk, North Carolina in 1903. World War I broke out in 1914. So the Wright brothers had achieved powered flight in an airplane for the first time in 1903. 11 years later, World War I broke out. So airplanes were a relatively new technology still, and that's why at the very beginning they weren't being used. The dirigibles, the blimps, the lighter-than-air aircraft were more reliable. But airplanes are different. Airplanes are what we call heavier-than-air aircraft. They are not kept in the air because they're filled with something that is light. They're kept in the air because of the shape of their wings. The way that airplanes' wings are shaped is sort of a curved shape. What it does is it forces the air that is passing over the wings when the airplane is moving forward. Now, the airplane has to be moving forward for this, but it forces the air that's moving over the wings to sort of spread out and become less dense because it has to pass over the curved shape of the wing. Meanwhile, the bottom of the wing is flat, and so the air that's passing under the wing does not have to spread itself out. The molecules of air passing over the wing have to spread out to get over that curve. The molecules of air passing underneath the wing don't. So as the airplane moves forward through the air underneath the wings is more dense. The molecules are less spread out than the air above the wings. So the air below the wings is more dense, and so it creates lift. So as long as an airplane is moving forward, now this is only if an airplane's moving forward. If an airplane is sitting there stable, it'll fall completely because no lift is being generated. But as long as an airplane is moving forward through the air, the density of the air underneath the wings will be greater than the density of the air above the wings, right? More dense here, less dense here, and it'll create lift, and the plane will stay in the air. That's the difference between an airplane and a hot air balloon or a dirigible or a blimp. The hot air balloon or the dirigible or blimp stays in the air because it's filled with something less dense than air. That's why it's called a lighter than air aircraft. An airplane is heavier than air. It stays in the air because of the lift that's generated as it moves through the air by the shape of the wings. So these airplanes, their maximum speed was about 70 miles per hour. And that doesn't sound very impressive to us. We go 75 miles an hour or faster down the highway all the time. But these were fairly light aircraft. The wings were made of wooden frames with cloth or canvas stretched across them, just like the dirigibles were. Very few components of the airplane. The bodies of the airplane were mostly made out of wood. Not too many components of the airplane were actually made out of metal. So two guys could basically take a World War I aircraft and lift it up on their shoulders and carry it around. It's really not that heavy. And so 70 miles an hour was fast enough to generate enough lift to keep this thing in the air. And it's really almost kind of like a beautiful thing to watch. These airplanes, they're not traveling very fast. They look like they kind of float in the air. And airplanes of that era flying through the air, it almost looks like almost like a graceful sort of floating, dancing type motion. But airplanes were nevertheless, even at only 75 miles an hour or 70 miles an hour, they were still a much harder target to shoot down than a big, old, slow, floating blimp or dirigible filled with hydrogen. Airplanes were faster, they were smaller, they were more maneuverable, so it was a lot harder to shoot those down. And so airplanes eventually replaced blimps as the primary means of observing the battlefield. Of course, it was very quickly understood that whoever controlled the air over the battlefield had a huge advantage because they could observe the enemy positions and they could help target their artillery better. And so, realizing that controlling the air over the battlefield was important, many airplane pilots began to carry weapons, began to carry a gun with them. And when they encountered enemy aircraft, they would take their gun, their pistol, and they would try to shoot the enemy pilot and kill him. Of course, that's very, very hard to do. I mean, think about it. They're traveling 70 miles an hour piloting a plane. You're traveling 70 miles an hour piloting a plane. How do you aim your pistol, right? To actually hit a target as small as a man's head who's piloting another plane. So it was the French, actually, who initiated the idea of mounting a machine gun, as you see here, on the front of an airplane. Either up on the wing or actually more commonly, they were down here in front of the pilot himself so he could reach up and pull the triggers. Because with a machine gun, you can spray a sort of a cloud of bullets, and there's a much better chance at actually hitting something. With a cloud of machine gun bullets, you might actually tear up the enemy's wings and cause the plane to crash, or tear up its tail and cause it to crash. You don't have to hit the pilot to bring the plane down. You have a better chance of hitting the pilot with a spray of machine gun fire as well, of course. But with enough machine gun fire, you could destroy an enemy's plane's wings and cause it to crash. So the French conceived of the idea of mounting a machine gun on the airplane. Unfortunately, in their early tests, they ended up the pilot ended up shooting off his own propeller with his machine gun. Of course, that was very bad news. It was the ingenious Germans, a German named Anthony Fokker, Fokker, Anthony Fokker, who developed and invented a machine gun called the synchronized machine gun. And this machine gun was synchronized. The firing of the machine gun, bum, 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 right? The firing of the machine gun was synchronized with the rotation of the propeller, so that the machine gun bullets were only passing through the path of the propeller when the propeller was out of the way. When the propeller was in the way, the machine gun bullets weren't passing through. When it rotated out of the way, the machine gun bullets would pass through. And so as the propeller rotated, the machine gun was firing as bum, 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 bum. And the bullets were passing right through the path of the propeller without hitting the propeller. A synchronized machine gun. And so for a time, that gave the Germans a huge advantage in aerial combat because they could shoot down enemy planes with their machine guns without shooting off their own propeller. But of course, eventually, the British and the French, the Allied powers, they figured this out as well. And that ushered in a whole new era of aerial combat in which fighter planes were fighting against each other in what were called dogfights in the sky. And as a result of that, then, fighter pilots became sort of the new romantic heroes of the war. In a war where it was very hard to be a standout, it was very hard to achieve any kind of individual heroism because the war was mostly fought by these sort of masses of men moving across no man's land, sort of faceless and anonymous masses of men, and then they're being gunned down, and it was masses of men in the trenches firing their guns and their artillery. There weren't very many opportunities for individual heroism, romantic heroism, but these fighter pilots, because they were mounting this brand new technology that allowed men to fly in the air and allowed them to joust and duel, almost like knights in the medieval times, they became this sort of new type of hero. And the greatest fighter pilot, they called them an ace, a fighter ace. The greatest fighter ace of the war was a German named Baron Manfred von Richthofen. He was actually a German noble, was why he had the title Baron. He killed 76 enemy planes during his career before being shot down himself with just a few years left in the war. But his squadron, they painted their aircraft colors, bright colors, to try to intimidate enemy pilots. And his plane was always painted red, which is why he was known as the Red Baron. So Baron Manfred von Richthofen, the most famous fighter pilot of the war. The most famous American fighter pilot was Captain Eddie Rickenbacker. Eddie Rickenbacker, ironically, was of German descent, but he was from Columbus. And he was, before the war, he was a race car driver, so kind of appropriate. But he shot down 26 enemy airplanes. You say, well, he didn't shoot down very many, but remember, the United States is only going to be in the war at the very end. So Eddie Rickenbacker was really only in the war for about 8 months, and he shot down 26 airplanes. The Red Baron was in the war for 3 years, and he shot down 76. So in some ways, you could say Rickenbacker was shooting enemy planes down at a higher rate than the Red Baron was. And the Red Baron ended up dead, shot down toward the end of the war. Eddie Rickenbacker came back from the war. But it really didn't change. Airplanes didn't really, again, change the outcome of the war. It didn't break the stalemate in the trenches, and it didn't change the outcome of the war. So one last type of technology that was introduced during the war that, again, it was hoped would break the stalemate in the trenches was poison gas. So this is chemical weapons. So it was realized that there were certain kinds of gas which are toxic to humans. Which could cause humans to create a toxic, even sometimes a lethal response when they were exposed to this gas. And you could compress gas. You can compress gas into a shell and then fire that shell out of a cannon through the air. And when that shell hits the ground, it bursts. And when the shell bursts, all the gas is released, and the gas then begins to spread. And if there's a little bit of a breeze, it spreads very quickly. And so the idea was that before you make an attack across no man's land, you could fire a gas canister, or you could fire, as you see in the picture here, many, many gas canisters at the enemy trenches, and that the gas canisters would open up and they would release their gas, and the gas would affect the soldiers who were defending the trenches and knock them out of commission so that the soldiers who were coming across no man's land would be unopposed. The enemy soldiers in the trenches would be affected by the gas, so they wouldn't be there to fire their rifles, their machine guns, their artillery, and they wouldn't be able to defend themselves when the infantrymen coming across no man's land finally arrived. The very first type of gas that was used during the war was called chlorine gas. And it reminds you of chlorine, the chemical that's used in swimming pools to keep them free of germs. Same thing, except the chlorine that's put in swimming pools is a liquid, not a gas. Chlorine gas, when you breathe it in, it irritates the inner lining of your throat, all right? And it's what's called a choking gas, because what happens is you begin to cough, right? When you breathe chlorine gas in, you begin to cough, and the inner lining of your throat becomes irritated, and the muscles surrounding your throat begin to spasm. They begin to spasm like this. And finally, if you breathe in too much of this and you cough too much, and your muscles just seize up, and it chokes you to death. It doesn't choke you to death. It chokes you for a bit. It cuts off your airway, and you end up, bent over on the ground coughing and unable to get a breath. Actually, chlorine gas usually didn't kill people. It affected them long enough to sort of incapacitate them for a period of time. But it usually wasn't lethal. One of the main reasons it wasn't lethal was because it had a very noticeable smell and color. It had a sort of a greenish color, and it had a noticeable smell. Same smell that you smell in an indoor swimming pool, but that's liquid chlorine, so don't worry. And so you could see it and you could smell it. And so before it could really affect you, you could get your gas mask on to filter the air and filter the gas out of the air and protect yourself. So chlorine gas usually was not breathed in such large amounts that it killed people. Usually people knew they were under attack, and because gas is more dense than air, it tends to sink down. So people could get up once they were under attack from chlorine gas, they could kind of get up to a higher space above where the gas was settling down. They could get their gas mask on. So chlorine gas tended not to kill people. Um, Another type of gas that was then invented was called phosgene gas. And phosgene gas was much more effective because phosgene gas was colorless and odorless. And you didn't begin to feel its effects until you had breathed in too much of it. So, phosgene gas, colorless, odorless, you breathe that into your lungs. And when you breathe phosgene gas into your lungs, it irritates the inside of your lungs. Effectively, it makes your lungs think they're being infected. They've got an infection. And so you know how in an infection, you begin to, like if you've got an infected, you've got a cut or something, you get sort of pus, right? That gets up under there. What happens is when you breathe in too much phosgene gas, your lungs begin to fill with fluid, begin to fill with pus, and it suffocates you. You essentially drown as your lungs fill up with your own pus. Right? You drown in your own fluids. It's a suffocating gas. And again, it was much more deadly because it was colorless, it was odorless, and you didn't notice that it was affecting you until you had breathed in so much of it that it was going to kill you. So chlorine was much cheaper to produce, but phosgene was much more likely to kill people. You didn't necessarily need a gas to kill people. You just needed it to incapacitate them. So thankfully, phosgene was not used nearly as much because it was so expensive to produce, um, but it was deadly. A third gas that was then developed during the war was called mustard gas, and this was in some ways it was the most effective gas at all of all because you could protect yourself from phosgene by wearing a gas mask. And phosgene might kill you, but if you suspected you were under gas attack and you had your gas mask on, it would protect you. The third kind of gas that was developed during the war was called mustard gas. And this was horrific because you didn't have to breathe it in for it to affect you. It created what this gas did was it settled on your skin or it settled on any kind of soft tissue and it created chemical burns and blistering. So this one, even if you were wearing a mask, a gas mask, it didn't protect you because it could settle on your arms or on your legs. It could even soak through your clothing, and it would cause a chemical burn that was extremely painful and a blistering that was extremely painful. And even though it didn't kill people, it would incapacitate people, and it incapacitated them much longer than chlorine would. So with mustard, with chlorine and phosgene is more deadly, but as long as you're wearing a gas mask, you're fine. But with mustard gas, it was called mustard because it was yellowish and it had a sort of a sour smell like mustard. But with mustard gas, you could be wearing a gas mask. You weren't protected. It would soak into your clothes, it would burn your skin, and it would incapacitate you. It wouldn't kill you, but it would incapacitate you. Now, if you didn't have a mask on, if you got it in your eyes, it would cause your eyes to blister. If it got it in your mouth, it would cause the inside of your mouth. If you breathed it in, then it was lethal because the inside of your lungs would then blister and become irritated. You begin to cough, and the more blistered your lungs would become, the more brittle they would become, and you would begin to cough more and more violently until chunk by chunk you coughed out your lungs. So if you breathed in mustard gas, it was lethal. Most people didn't die of mustard gas, but they suffered very painful injuries from burning and blistering. And even at that, gas didn't break the stalemate. Even the use of poison gas didn't break the stalemate in the trenches, and it didn't impact the outcome of the war. Both sides had it. So, unfortunately, all of these technologies, none of them broke the stalemate. None of them brought the war to an end sooner. They just made the experience of fighting the war more horrific and more painful and more deadly for the soldiers who had to fight it. So that's a rough lesson. But they're going to have to try other things to win the war, and we'll get to those in future lessons. I'll look forward to teaching you those lessons. So until then, take care of yourselves, stay healthy, stay safe. Bye bye, modern world history students.